Hey, welcome to GeoSolve. In this video, I have another Olympiad question for you. I will solve the question with two different methods. Let's start with solution method 1. First, let's draw a perpendicular line from point C to line segment DB. And let's call the intersection point as E. Then, since triangle CEB is a right angled triangle, angle ECB will be 45 degrees. Since this is an isosceles triangle, let's call its equal sides as X. Then, using Pythagorean theorem, we can write the following equation. Solving this equation, we can find x equals 3 times square root of 3. Observing the line segment DB, we can conclude that DE equals DB minus EB. From here, we can write DE equals 13 plus 3 times square root of 3 minus 3 times square root of 3. And that gives us DE equals 13 units. Now, let's focus on this shaded triangle. Applying Pythagorean theorem on this triangle, we can write the following equation. And that will give us DC squared equals to 169 plus 27. From here, line segment DC can be found as 14 units. Now, let's call this angle in the same shaded triangle as alpha. So we can write sine and cosine of angle alpha as follows from the shaded triangle. Using compound angle formula, we can write cosine 60 plus alpha equals cosine 60 times cosine alpha minus sine 60 times sine alpha. Since we know all the values, we can write the following equation. And that will give us the value of cosine 60 plus alpha as 1 over 7. Now let's clear the screen for the next step. Then let's focus on this shaded triangle. Let's apply cosine theorem on this triangle for line segment AC. Plugging in the values we know, we will have this equation. From here, line segment AC can be found as 16 units, which is our answer for the first solution. Now let's clear the screen for solution method 2. First, let's assume a point E on line segment DB such that the line segment DE equals 10 units and line segment EB equals 3 plus 3 times square root of 3. And draw two separate lines connecting point A to point E and point E to point C. Then triangle DEA will be an equilateral triangle. Now focus on this triangle. We can apply cosine theorem on this triangle to find the length of the line segment EC. Plugging in the known values, we have this equation. Solving the equation, we can find EC as 6 units. Now, let's call this angle as alpha. Applying cosine theorem to same shaded triangle, we can find the value of alpha. Plugging in the known values, we have this equation. Now, solving the equation for cosine alpha, we can find cosine alpha as 1 over 2. Then, alpha will be equal to arc cosine of 1 over 2. Then, alpha will be equal to 60 degrees. And we already knew that the angle AEB is 120 degrees. Which means that angle AEC is 180 degrees. And that means that the yellow line segments, namely AE and EC, must be on the same straight line. And from here, we can simply find the length of the line segment AC as 16 units. And that will be our answer. I'll see you next time.